So, yeah, that's what I'm saying. There's no such thing we can do. This is the thing, and the other guy is also a rental. Yeah, this is doesn't need to be there physically. So it's tricky to restart.
Hello, can you hear me? Okay, so, but you have to be connected to the session to hear me, I guess. Does anyone else hear me?
We should see him there. Yes. Okay, hello?
Hello?
Yes, hello everybody. So if you've ended up actually in OPSEC here, I hope that was your intention. If not, you can still leave the room and maybe close the door to make it a bit more silent, which would be fantastic. Okay, so welcome. So we actually have quite an extensive agenda today for OPSEC. Now, before we go ahead, let us first start with some administrivia here. So can you click on the next one? Okay, so before we start, we're going to give like the blue. Please spread them around and fill in your name so we can get like a nice room again the next time. Also, before we start, anybody willing to take the role of a JavaScript on him? And we need somebody to be volunteer for taking minutes. It's an online tool. Everybody's looking at their screen right now. Any volunteers? You don't have to do it alone. If you like more than one volunteer, then you can sort of like share the pleasure. Joe, thank you. It's for scribe or minutes? Jabber. Okay, Jabber. So minutes, please. Somebody. Oh. Any like minutes before we have somebody? We cannot really start. Okay.
Thank you,
Thank you. Thank you so much. So the first thing is you've probably already done like a few of the sessions here. We have this note well, anything you say, will be recorded and will be public, information. Please be aware of that. So then going onwards, before we actually start, so we did not really have a meeting at the previous two IETFs. Another new element is, I would like to formally thank here also the Kiran Kumar Chitimaneni, who has been the OPSEC co-chair for for quite some time. So thanks actually to him for all his effort and making this working group quite a success actually during this time. So thank you. And I also would like to introduce a new co-chair, Eric Vinke, sitting here next to me. So welcome.
Thank you.
So, and also with his coming, the aspiration is that you will see, the last couple of months, the interaction on the email alias has been relatively light. And, with the arrival of Eric here, the intention is that it will become like super active again and, with lots of interesting discussions and interesting topics, going forward. So also in the, between about a year ago and now, we did have like two RFCs published. So RFC 7610, which is also a BCP. And we also had RFC 7707 published here. For the rest, the remaining work, it is, nothing really in ISG processing and not really anything else, happening as such at this point in time.
So let's start the sharing of the mic here. As Gunther has said, little traffic on the email list, but at least we have now two brand new drafts in this OPSEC working group that will be presented today. So there are new live coming in OPSEC there. And if you look about the charter and the milestones page on the website, all the milestones has been completed, meaning that all documents are becoming now RFC. But if you look at the charter, the job is not yet done. The goals are not finished. And I think it's kind of normal for this kind of working group to continue the work as long as we are deploying networks and deploying new protocols and new systems. And we welcome your feedback here on this one. So agenda bashing. Administrivia, that's what we are doing. We will get Daniel speaking about SACEM. That's another working group, but we think that OPSEC is a working group, is kind of the border between operation and security. So when we see some draft from the security having an operational impact and vice versa, I think it's very important that we get presentation of those drafts by the authors in this working group, even if they are documented in other working groups. Then we see remote, so cross fingers whether it will be working. And our speaker is based out of Japan. So if you do the math, it's very, very dark night ways now. And it will be about the threat analysis, about all the IPv6 transition technique. I will present the work done by KK and Mary Kay about OPSEC for IPv6. This will be 1 hour in total. Then a short break of 20 minutes, if not mistaken. And we continue with Stefan. So we need to find another minute taker for a while, presenting a brand new draft as well. And now we'll present MLD security. So that's again, it's a PIM document, but I think it's very worth to present it in OPSEC because it has operational impact. Then Fernando will present updates on all those drafts. So he will be taking the floor for 45 minutes, and then we will be finishing the day. Any comment on the agenda? Okay, let's proceed then. Daniel? And if you want the clicker?
Yep. Yeah, and please position yourself in the pink box, which you are already.
Yep, I'm here. Okay, so I'm Danny Haynes, and I primarily work in the SACM working group.
Can everybody hear him?
No? Is this on? Is
Take the mic closer to you. It's movable. It's mobile mic.
that better? Here we go. So we'll go back real quick. So just basically for a quick introduction, I work primarily in the SACM working group, which is a security automation and continuous monitoring working group. And basically, we are chartered to develop data models and protocols for endpoint posture assessment. And as we found out in working in this area, it's a very broadly defined space, and we ran into some challenges just trying to focus on a particular problem, and that's kind of where this vulnerability assessment draft came into play. So let me give you some background on that. Maybe I'll just hold it. It might be easier. So basically, the vulnerability assessment scenario draft is a operational use case that basically starts with an organization taking in vulnerability description data. And in this document, vulnerability description data is essentially information that lets you know whether or not an endpoint is vulnerable, whether it be a particular piece of software has a flaw in it, or if there's certain configurations that may put it in a vulnerable state. Basically, think security advisory when you're looking at like Microsoft or Red Hat or Apple or whatever. And basically, an organization takes this data in and stores it in a repository where it can use it at some point in time to carry out assessments as to whether or not its endpoints are vulnerable. And part of SACM is we have to, get this information off the endpoints. That may be software inventory data, what software is installed, what hardware is on your endpoints, and also the different configuration states of that software. And basically the interaction, the endpoints report to the server, which can then put that information in the repository, and you can do evaluations, and we'll talk about that in a little bit more detail after. And so basically the assessment scenario, the use case breaks down into a few different steps. The first is, knowing what endpoints you have on your network, being able to identify them. And then the next part of that is basically in a kind of an ongoing basis, which we don't specify, what that basis is, collect information on your endpoints. And this kind of gives you knowledge about those endpoints that you have identified on your network. Then, so the next part is the vulnerability description data, and that's, like I said, is basically the security advisory. And then there's endpoint applicability and assessment, which is basically determining first, is this vulnerability description data or security advisory applicable to my endpoint? And if so, do I have the information I need to make the determination of whether or not it's in a vulnerable state, or do I have to go and find additional information and make an assessment? And then lastly, how do I present that information or the results of that evaluation, which can be used to determine, compliance and things like that. And then, so basically, this use case is a very specific, problem that we're trying to solve across the broader SACM use cases. So as I said in the beginning, with SACM, it was a very broad area, and we were having trouble kind of making progress, and we decided that if we come together and focus on a very small piece of that problem space, we can just work from there, drive it to the data models and protocols we need, understanding that we need to leave room for extensive, to extend those protocols and data models to support our other needs, but really just try to work that to the end. And so far, it's it's helping us focus our work much better. And at the end of the day, as part of this scenario, we use it to get input from people that actually are going to have to or want to use these data models and protocols to understand what information do we need to collect off the endpoints. What are the different interactions between the different components throughout the life cycle of this scenario, and try to understand what protocols kind of fit that area, and just kind of how it all works together, really with the end result of being really just focusing our work to solve this particular problem. So if you guys, I don't know who's read the draft, but there's a handful of assumptions that we go through with this, mainly because if we don't do that, again, it becomes a very intangible problem. So by scoping it down, we just work to really kind of cite our focus in. And some of the big ones are that we don't really talk about how an organization decides which vulnerability description data it wants to use, what that vulnerability description data looks like. That's all kind of just assumed that an organization can get that information and put it into a format that its tools can use, and it can make a determination of whether or not the endpoint is in a vulnerable state. And then lastly, we also assume that obviously the enterprises have a way to collect information off their system or their endpoints, and also evaluate it to make this determination. And there's some other assumptions, but those are the few big ones. So the first part, as I mentioned, was the endpoint identification and data collection. And really, in order to collect information off your endpoints, you need to know what's there. And this may come in the form of, when you put an endpoint on your network, you may have some step that kind of registers it with your enterprise, or you may be getting this information from external sensors looking at traffic on your network, and can say, oh, okay, I'm getting packets from this particular endpoint, and can have an idea of what's out there. And you want to look at things obviously like IP address, MAC address. Those are kind of some of the very basic identification information that we care about. Of course, at the end of the day, it's going to very much vary and depend on your enterprise's particular deployment situations. And so basically, once you have that, you want to take that information and put it in a repository where you can either use it right away, or use it to do follow-up evaluations. So right now we're focused on determining whether or not an endpoint is vulnerable, but you may want to use the same data to determine just what software do you have installed across your enterprise. Are you compliant with particular policies and things like that? So it's kind of the big part of having the repository is to basically not require that you have to go and get this information all the time, every time you want to check it. So then this is actually kind of a combination of two steps in the scenario, but I just did that for kind of making it easier for me to present. And so the first part is basically the vulnerability description data, and we just in the scenario talk about the different information needs that you have for that, and that's things like you want to know about what software that it applies to. Vendors may have identifiers associated with the particular vulnerability description data for their platforms, different things like that. There may be some type of logic in there telling you, if you have, this piece of software installed at, this version, you're vulnerable, things like that. And really, what you need to do is once an organization takes that in, you want to put that somewhere, because you, one, may not want to perform all these assessments right away, or you may want to, so that's one part of it. And then the other part is basically, you want to keep a record kind of the different vulnerability description data over time, because one, it may be updated by the vendor, or you may just want to keep it for historical purposes, saying, oh, I did an assessment at this time and this was my results. Here's what I used to drive that assessment. And then, so after that, as part of that vulnerability description data, you may also be able to look at, basically what initial data you collected off the endpoint and say, okay, does this particular vulnerability description data apply to me, right? So you might have, say you have a Linux box on your network and you plot some vulnerability description data from Windows. You're going to be able to look at that and say, hey, I don't obviously care about that because it doesn't apply to my endpoint. And so that's kind of another part. And in some cases, especially those, you may be able to just look at that software inventory information you collected at the beginning kind of as a ongoing process and make that determination. However, in some cases, that it's not that easy to determine whether or not something is vulnerable. It's not always just a software version to look at. You may need to check some registry setting or something like that. And basically, we want to enable some secondary assessment where you can go out and ask that endpoint, what's your state for this, and you pull that information back to make that final determination. And then lastly is the assessment results, which are basically, what endpoints on your network are in a vulnerable state. And really you care about knowing what that endpoint is, what did you use what vulnerability description data did you use to make that determination? What data were you evaluating that against? Because maybe you had old data and that can potentially throw off what the actual results are. So, and there's a lot more information listed in the actual scenario. This is kind of an excerpt of that. And so basically that's kind of at a high level, the process that we're going through, and to kind of drive, what solutions we work on to solve this problem. And wrong button. So that leads me to this kind of next slide here, which shows, how the different data models and protocols we're working on does this and potentially can be used. And I'm not going to go over that now because I'm going to talk about that in a little bit more detail tomorrow at the SACM session. But I'll just kind of give you a quick overview of the actual solutions that we're working on. So the first thing is we need a way to exchange this information between our endpoints and the server. And what we're looking at to do that with is basically the NIA protocols, which are out of the IETF, as well as some additional TCG specifications. And really this is kind of outlined in how to use this is outlined in the endpoint compliance profile, which is another TCG spec that was submitted to the IETF. And really it shows, how do you use NIA, how do you use SWID to, collect software inventory data off of an endpoint and report it back. And it has additional capabilities such as, if you detect a change, send the updated software inventory data to the server. And that's really where that SWID message and attributes, that's M&A, what that stands for. That's an extension to the NIA PA-TNC protocol to support carrying SWID tags. In addition to this, so that covers kind of the software aspect of the data collection, but there's also information about the configuration of that software. And we have brought in OVAL, which is the Open Vulnerability and Assessment Language, as a starting point for that. That is a effort that been going on for 13 or so years. And in doing so, we've learned, a lot about it, a lot of the challenges, in trying to use it, in an enterprise. And so we'd like to take that work and really build off of it and really improve on, all those lessons learned we've learned over that time. And really, I was very happy to come talk to you guys because you guys may have more insight into other standards, data models and protocols that we should be considering for this work. And I don't know if anyone has any, off the top of their head or things that, might be look useful here, but if you do, please let us know. Okay. Then, so just to wrap up, we'd definitely like to hear any feedback you have, on the draft. Does it look like your organization? Is that how they do things? Is there key information that we're missing? Just definitely let us know. We want to make sure we have a very complete scenario that covers what people need in their enterprise. And I guess I just want to also briefly discuss two other specifications that may be useful in this area, and that's server discovery and validation, which basically is basically a protocol that allows you to determine, if you're that endpoint on the network, how do you find a server and how do you ensure that it's a trusted server that you should communicate with? And then there's also IFM segmentation, which basically allows you to break up that data that you'd want to send from the endpoint to the server into more manageable pieces across the network. And that's primarily it. The last two slides were just the appendix, and you can read those later.
We have time for a couple of questions, if any.
Lucy Lynch, NSRC. This draft has made a lot of progress since last time around. I'm pleased to see it scoped to enterprise now. I do have some questions about the security considerations and the server discovery piece, since there's a handshake there between both the endpoint and the server. And I think the server discovery mechanism assumes that initial handshake. But given the side channel possibilities here, what are you doing for those endpoints being capped by an unknown server?
So we haven't pulled that in yet, but that's something we need to consider. We're not currently working on the server. No.
Okay.
We're not working on the server discovery piece right now. So we haven't really thought a lot about it, but Dave, you may have, I don't know if you want to jump in.
Yeah, Dave Waltermeyer. I'm a co-author actually on a number of the specifications that Danny's talked about. The server discovery basically uses DNS SRV records as a way to identify the server that the endpoint will communicate with to provide its software inventory information. So that can be mitigated through things like DNSSEC and other capabilities to ensure that only authorized DNS servers are providing that information to the endpoint.
Can be. It's just not currently in the drafts, and I'd like to see something reflected.
Yeah, we can add a tracker
Thanks.
to consider that as part of it.
One thing I also wanted to point out is one of the existing areas of work the IETF has been doing within MILE is a draft called ROLI, which is basically about lightweight information exchange using AtomPub as a protocol. And that's one of the efforts that I'm working on to try to address some of the information repository kinds of considerations that we need to address to support this scenario. ROLI and AtomPub can basically be a method to provide a repository of both vulnerability information as well as SWID tag information. And it potentially can provide a federation mechanism to allow vendors to publish their vulnerability data and to allow organizations to discover that information, probably again through SRV records associated with the vendor's domain, identify the collection of vulnerability records, pull that information down, and then use it as part of this scenario. We'll be talking about that in the MILE session immediately after this one, if anyone's interested.
Okay, if there is no questions, we'll switch speaker and go to Marius. And by the way, how many people have heard about SACEM before today? Okay, 2, 3. So Marius, can you try to activate on your side?
Hello, can you hear me?
Yes.
Okay.
So if you have to flip slides, just say the number, okay?
Okay, thank you. So, hello everyone. My name is Marius Georgescu. I am from Nara Institute of Science and Technology in Japan. It's quite early here, so if I look a bit tired, that's the reason. Thank you for coming today. I'm going to talk about a draft, which I'll start by saying a few things about the history of the draft. So I did a presentation in IETF 94 at an early stage of the project, and at that time I was thinking about writing this draft, and yeah, the suggestion was to associate it with the OPSEC working group, and yeah, that's how I ended up presenting today here. So can you move to the next slide, please?
Yes.
So yeah, a bit about the draft motivation. I'm pretty sure everyone knows by now the IETF IPv6 is not backwards compatible. Yeah, that means the internet will have to undergo a period through which both protocols will have to coexist. And for now, we only have 5% of worldwide internet users with IPv6 connectivity, which is a problem considering that IPv6 was introduced in 1998, so almost 20 years ago. In this context, we are trying to tackle some of the implications of using IPv6 transition technologies in the network. So next slide, please. As you can see from this slide, in 2000, this is a chart of the evolution of transition technologies in the IETF, or a part of the transition technologies. Actually, you can see there wasn't too much diversity at the beginning, but now there's a lot of diversity. So aside from essentially being a problem, it got a bit more complicated through the diversity of the scenarios and the use cases. So the implications are essentially more complex because of it. Next slide, please. So yeah, this draft, there is already a published RFC on the security considerations of using IPv6 transition coexistence mechanisms, namely RFC 4942. However, this draft is trying to put the context around the transition technologies and also offer some structure by proposing the STRIDE threat classification as the base of a threat model. Also, we are considering a generic classification of IPv6 transition technologies, mainly to reuse some of the threat analysis done for other types of transition technologies. And we did that in a draft that's associated with the benchmarking working group. Also, the draft contains a list of threats and mitigation solutions for protocols associated with IPv6 transition technologies that were proposed in the IETF. So, of course, the list is non-exhaustive, and it contains sometimes, or it doesn't contain sometimes mitigation solutions, and we would definitely need your feedback on this. Some collateral contributions of the draft would be that we are proposing a format to maintain threats associated with protocols proposed in the IETF, and also a way to organize security considerations sections for the protocols proposed in the IETF. So yeah, this is the draft overview. Next slide, please. So now the main part of the draft is the thread model. So the thread modeling steps we are proposing are first and foremost establish the function. So the function of the transition technology has to be clearly identified in order to understand what is the attack surface or what the threats could be. Also, another important step would be identify the generic category, because once you have that established, you can reuse some of the threat information you had from other well, transition technologies in the same category. Also, an important step would be decompose the technology. So understanding the basic use case or a customized use case requires building some sort of diagram in which you analyze what are the nodes, how do they interact with each other, all of that. The most important part is, of course, identify the threats. And here we propose a couple of sub-steps. And here the stride, or the stride mnemonic and thread classification is used at first to do association of the threads with the elements of the data flow diagram, which we are proposing as a tool to build diagrams for decomposing the technologies. Then we analyze the level of trust of the entry points, and then associate some likelihood values deduced from those. Of course, document the threats, detailing the format, and analyzing some of the complex threats that can result from the interaction of the protocols or of the basic threats that were introduced by the protocols. The last step would be, of course, review what was discovered, repeat in the context of change of technology, and validate through empirical means. Next slide, please. Okay, so before we go any deeper, I want to give a short description of STRIDE. I'm pretty sure most of the people have heard about it. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, and is a threat classification mnemonic. It can give basic mitigation solutions. So if the threat is associated with spoofing, you would want the desired property to be authentication, so you have to improve the authentication. Some examples from the network elements perspective. So, for example, in the network, the spoofing would be, an example of spoofing would be IP address spoofing. Also, like it might be hard to wrap your head around elevation of privilege in this context, but for example, accessing the privileged parts of the network can be associated with this type of threat. Next slide, please. Okay, so in terms of establishing the function, as I was saying, I think the function for the IPv6 transition technology needs to be clearly documented. So depending on the context, of course, the technology can incorporate multiple services, and as an example, in the next slide, for dual stack. So next slide, please. Yeah. So for dual stack, the transition technologies, the function would be to ensure a safe data exchange over a dual stack infrastructure. So we are mainly focusing on the forwarding capability. So this includes, of course, interior gateway routing solutions, and then we start with the assumption that services like address provisioning, DNS resolution, or exterior gateway routing are performed by other nodes within the core network. So we are excluding these as potential attack surface. Next slide, please. Okay, so in terms of identifying the generic category, we put together a list of categories. So we said dual stack, single translation, double translation, and encapsulation. We think this is a exhaustive category group that in which all of the transition technologies can fit. So, for example, for dual stack, we have dual IP layer of operations as they were described in RFC 4213. In terms of single translation, we'd have NAT64 and Ivy, for example. Yeah, this doesn't contain all the transition technologies existing or proposed today. For double translation, to continue, 464X-LAT is an example, MAPT is another. In terms of encapsulation, we would have DS Lite, MAPT, lightweight 4/6 or 6RD as examples. Next slide, please. Okay, now in terms of decomposing the technology, since this is based on it essentially was inspired by application or web application threat modeling. I tried to map some of the concepts that were defined there to network elements. So I had to redefine some of those elements. I already have some feedback that it's not such a great job, but yeah, your feedback would be greatly appreciated. So to improve these. So for the definitions, so for now are for external entity. We said represents a network node which is outside the control of a network provider. So it's essentially outside the trust of a network provider. Process, we said, okay, basically it's supposed to be a middle box or a network node which processes network data. But I think, yeah, this, for example, can definitely be improved. And I'm not sure exactly how for now, but I know it's not the greatest definition. Data store represents a node where data is stored. Again, another one that definitely can be improved. Data flow, I think it's sufficient. Data exchange between network elements, and transponder is similar. So the border which marks the part of the network considered outside of the control of a network provider. So these were the basic elements I think are needed in order to build a basic use case diagram. So next slide, I'll show you an example of that, I think. Can you move to the next slide, please? Okay, so this is a data flow diagram for those stack transition technologies. So essentially, we said, okay, the simplest use case would be we will have considering 3 domains and a network provider that is involved in this process. We'll have domain A, which is dual stack, the core domain, which is under the control of the network provider, and domain B, which as well is dual stack. And we are assigning as functions. We have let's say client and server or customer and provider, and in this context, we'll have on the client side, we will have a customer device, which is an external entity. In the middle, we will have a process, which is the dual stack node. And at the end, we'll have a provider data store, which we're assuming that the customer device will try to get to. And essentially, the data flow is exchanged over IPv4 or IPv6. So this is the basic use case data flow diagram. Another important point would be about the protected assets and the entry points. So essentially, we are looking at this as the whole system. So we are trying to protect every element of the system. So that's why every element of the diagram has a P, which stands for protected. And also every element of diagram can be an entry point. Again, this diagram as well could be improved by specifying which are the potential entry points, like physically. Is it an interface? Is it something else? So yeah, this is again, this is to start with. So feedback would be greatly appreciated. Yeah, next slide, please. Okay, now since specific elements of the data flow diagram can be associated with specific types of threats. So, for example, an external entity could be associated mainly with spoofing and repudiation. You can do an association with the elements of the diagram. So, for example, you know the customer device is an external entity. So, of course, that can be by association. The threats could be spoofing and repudiation. So this is the stride proposed, or how stride was used by Adam Shostak in I think 2008, and it was an example of how stride could be used at that point. Yeah, next slide, please. Okay, so essentially yeah, sure.
Sorry, just a quick time. You have about 5 minutes left.
Okay. Yeah. So essentially, from the level of the trust of the entry point, we can associate some likelihood of attack values, which are initial values for mitigating or prioritizing the mitigation solutions. So yeah, essentially, since the customer device, for example, is an untrusted entry point, the likelihood here would be high. So that's what the H stands for. Next slide, please. So yeah, in terms of documenting the threats, we propose the format. So that includes a short description, a threat ID, and yeah, let's jump over this slide, and I'll show an example of how the threats can be organized in the next slide, please. So yeah, this is a kind of a simplified version because I wanted to put the threats in a table-like view. So essentially, we will have the threat ID, which for now I said an acronym IETF TDB, which stands for threat database, and then the protocol, in this case ARP, like for the first threat, and then a serial number. And then a short description. So yeah, ARP cache poisoning is an example, and then the association with the stride element. So this can do most of the. It can be associated with most of the stride threats. So aside from the elevation of privilege, and then some mitigation solution that exists. So for ARP spoofing, we have static ARP entries or ARP watch. Yeah, next slide, please. So essentially, from looking at the simple threats, by looking at the interactions that could potentially exist between them, the impact or the likelihood can increase. The first complex threat that I gave an example of here actually says also another thing that we haven't really for the first. The impact would be increased, but we didn't really propose any way to measure the impact.
Marius?
Yeah, sure.
You try to speak. The quality of your voice is pretty bad for the last minute.
I'm sorry. I'll try to speak slower. So essentially, this slide is trying to say that we can have combinations of threats which can become complex threats.
Marius?
Yes.
Marius? It's not better. What I will do, I will jump to your last slide, and if you can try summary.
Yeah, sure. I will try that.
Meet support suggested in the room that he mute video, that we may get better through.
Okay, I muted the video. Is it any better now?
So go on. Marius, are you still there?
Yeah, I'm still here, but I think there's a lot of lag.
So go on.
Okay. Okay. So essentially, Okay, so can you hear me? I can hear some things. Not very well, actually.
So we are actually like kind of hearing you now. So please continue.
Okay, so essentially, yeah, I think I went through most of the thread model. We also have some collateral contributions. Essentially, the most important, maybe in my opinion, would be having a thread database maintained somehow in the IETF. I was thinking a draft maybe, and also a tentative way to organize the security considerations for protocols. Like if we can have some, instead of just generally writing about the threats, maybe some structure like what's the function, what like the steps that I already presented. So yeah, this is about it. I have some questions if there's still time. If not, we can just jump to questions like feedback from the audience.
As you are running out of time, any questions for Marius?
Yeah, Joel Yegley. I think you saw my comments on the references on the mailing list, and I think that's probably a reasonable thing to update. I think this is actually, as threat models go, this is pretty reasonable coverage of the subject area.
Okay, thank you very much, Joel. I've seen your comment, and I will update the references with the next version, of course. Thank you.
Okay. Thank you, Marius, for waking up so early.
No, thank you very much, everyone. Thank you.
Thanks.
By the way, where are the blue sheets? Anybody not signing them? Yeah. You know the drill, right? So thank you. So basically, that's about this OPSEC IPv6 draft. Revision 8 is simply fixing some typos and refreshing the reference. As you may remember, this document is basically a roadmap that tells, hey, if you want to deploy IPv6 and you want to do it in a secure way regarding the operation, please think about, for instance, logging, things about this, and we simply refer to other documents. It's mainly kind of a roadmap against all the documents. The big issue is that ID, Internet Draft, are becoming RFC, so we need to refresh the reference, but it's kind of easy to do. So now, topic of today is really, we started with KK and Mary Kay this document more than 4 years ago. We had a big momentum at the beginning. We wrote it in a couple of months. And now, basically, we fixed a few things after a couple of reviews. And we were not calling so much for working group last call as the author, because it's clearly, when you look at the text, that two authors are English native, and I am not English native, so part of my text is more concise, using a different style. So we wanted to make it more fluent for a book. But actually, that will become an RFC, so no need to get a very nicely written book, as long as the content is correct and clear. And we do believe that we have reached this situation. So we would really love, as the author, and I guess as a working group chair as well, that some of you review the document and say yes or no, at least get some momentum again around this document so we can push it into the queue and go forward. So that's really, really important. People who have read this draft that dates 2-3 years ago, like it. So if we can just spend 10-15 minutes to do it. Would I dare to ask for volunteers? Fernando, thanks. Fred, thanks. Lee, thanks, and thanks. Okay, so 4.
Cool. Thank you.
Thank you very much. And we're done for the first part. So we have a break now until 5:40. stay here, go outside, whatever. See you soon.
But you have to plug it in. Then you have the option. It's smart.